back on verse. I want to finish looking at this before tomorrow. Just to kind of get it done, because yesterday I looked at the other. Okay, that's annoying how that hovers. Yesterday I was looking at the other parts of these, right, of the verse language, Unreal Engine's programming language, expressions, primitive types, container types, a lot of funky stuff, not really that appealing. But now this is the interesting stuff. I mean, all of it's interesting, but like I think this is a good, interesting stuff. Hopefully, with failure, its failure system is very interesting, and then its effects and concurrency, and then a few other things. But yeah, I don't know. Yeah. If you so the thing about this language, right, is it's built for Unreal Engine, so it wouldn't really be applicable outside of the engine, which is kind of interesting. It means that like I'm not going to learn this language really. I'm just looking at it to kind of gauge well, to kind of like reap some interesting ideas from it. Like as far as I'm concerned, it's like a research language because it's not meant to be used outside of Unreal Engine. So we can learn from this language without committing to it. So, most languages treat control flow as a matter of true or false. Yes or no, 1 or 0. Do they? They evaluate Boolean conditions and branch accordingly, creating a world of binary decisions that often requires checking conditions twice, once to see if something is possible, and again to actually do it. Right. Okay. Verse takes a different approach. Instead of asking, is this true, Verse asks, does this succeed? It's an interesting way of doing it. I wonder if it kind of only works with its kind of like its virtual machine, its VM model, because when it hits an error, it rolls back like the calculations and stuff, which is funky. And surely like that's not faster, right? I don't know, but like it must be faster because otherwise you're just wasting valuable computation for like because like this is Unreal Engine, you know, like the game engine for making performant games. So like surely this distinction might seem subtle, but it changes how programs are written and reasoned about. Failure is not an error or an exception. But you can't just put you can't put a hyphen like that. It is a first-class concept that drives control flow. When an expression fails, it does not crash your program with an exception that needs to be caught. Instead, failure is a normal, expected outcome that your code handles gracefully through the structure of the language itself. Consider the simple act of accessing an array element. In traditional language, you might do this, right? Pretty much, yeah. But then Rust, you could do array index with a question mark to early return if it's a failure, and then handle the error outside of that, which I think is quite clean. This checks validity separately, or like use a try keyword, whatever floats your boat. Okay. In verse, they're unified. My issue is that like this just doesn't read nicely. Like this is if index is less than array.length, then value equals array index and process value, you know? It's like you don't have to store it for the record, but whatever. But here it's like if value equals array index, or like if value binds to array index, then process value. I guess if you're like that, it makes sense. If it doesn't bind, then there's an error. But it's just, I feel like you could do something more interesting than like an if statement. Then the array access either succeeds and binds the value, or it fails and execution moves on. And now undefined behavior. I mean, undefined behavior is very C++, but you know, this language is Unreal Engine is coming from C++, right? Like versus is meant to, I guess, not replace it because it doesn't seem like it's going to be that performant, but it will. You know, it's an alternative to C++. I don't know why they didn't do this earlier. By the way, like, why do they make blueprints instead of just making like a scripting language? You know, I don't know. I mean, blueprints was like a test in a way, but I'm not sure what they expected it. Like, did they really think that a visual programming language would succeed? because they're such a pain to orchestrate. But, you know, again, as far as I'm concerned, it's like a research language. It's just interesting. But it kind of sucks for people who use Unreal Engine, because now they can't use Blueprint anymore. I don't have to learn this funky language. Yeah, I mean, it's better. Like it's better than C++, sure. But like again, like in Rust, you have if let, right? If let some value equals array index. Like, it's the same thing then. But like, there's no rollback, you know. But okay. A fallible expression, or as I say, fallible, is one that can either succeed or produce a value, or fail and produce nothing. It's not the same as returning null or an error code. When an expression fails, it literally produces no value at all. I mean, it's like an option, right? The computation stops at that point in a particular path of execution. Many operations are naturally failable. Array indexing fails when the index is out of bounds. Map, yeah. Comparisons fail when the values are not equal. Really? So that's a failure. Division fails when divided by 0. Yeah, false always fails. Kind of funky. Why do they have true and false? So like not like fail or okay, you know? Yeah, it provides immense power, but like it's in a weird way. It means that like if I want to intentionally fail, I just put false question mark like somewhere random. It's like, how's that like how's that supposed to be intuitive to read? You can create your own failable expressions whose functions marked with the sides effect. Yeah, so it's an effect. This function does not just check conditions, it embodies them. If age is invalid, the function fails. If it is valid, it succeeds with the age value. Okay. And like you just assert statements like this, you know? Like there's no assert keyword. You just put it there, which I also find really weird to read. Like that's my main issue with this. Like building failure into the language is fine, but having it done like this, where you just put it blankly, is really weird. Like, yeah, I like this decides effect rather than like having like an optional type, return type. I mean, under the hood, it might be like a tagged union, whatever, but like from the programmer's perspective, it just may fail. Or maybe it's not that under the hood, I don't know. And then if it can fail, then you have like an assert keyword, and then if that fails, then it returns nothing, you know? Like that. That'd be pretty cool. Yeah, so they can only appear in a failure context. So if statement. Notice how the comma does what and does as well. Which is kind of weird. This if condition contains 3 potentially false failable expressions. One must succeed for the body to execute. If any fails, the entire condition fails. And control moves to the else branch. Yeah. The for expression creates a failure context. Hold on. Yeah. So it short circuits. The for expression creates a failure context for each iteration of the domain clause. Yeah. Similar to for. I mean, this is nice how natural this is. Like, you don't have to like you get something similar to a C or C for loop, where like you can, actually no, I'm lying. That's not true at all actually. But anyway, it's cool. Similar to for, the first expression creates a failure context with a domain clause. Pretty cool thing. The hell? Option not first. What's that? Optional type? It's weird that the language has an option type, considering like failable also exists. I mean, obviously there are other uses for optional than just error handling, but I don't know. Right. So a function marked as decides, you can put them anywhere, and then it'll fail, and then and then a fail can happen, whatever. I wonder if the main function, like, I wonder how many effects it's listed with. I wonder if you have to like list them as you add them, or if they like just have like, if main just has effects by default. Whether that be implicit or like you have to specify it when you write your program. Function bodies, failure context, yeah. Speculative execution. Changes to immutable variables are provisional. They only become permanent if the entire context succeeds. Functions that modify state in failure context must use the transact or the writes effect. Yeah. So what it means is that if I do anything in the function, and then like a failure happens, all those changes get undone. So I can't have a function mutate and then fail. Like, it just can't do that. Which is kind of weird, isn't it? Like, what if I want to mutate state before failing? I just can't do that. Or like, I have to use some other fail system that isn't failing, but like return like an option or something. Like, I don't really understand how that's meant to work. I wonder what implication that has. I'm sure it's well thought out, but like, right now I'm struggling to imagine that. Yeah, class functions. Okay. Logical operators, yep, and a not. Or what? Not XP expression. It succeeds if expression succeeds, but all effects of expression are thrown away. This is a way to try to see if a complex expression will succeed. It succeeds if this succeeds, but all effects of expression are thrown away. What? Bro, call it an interesting use case, but like, why would you put not just to do that? Like, that is not intuitive at all. Just putting it there. Like, this is why I see this as like a research language right now. Because like, who is writing not in their code happily, you know? Like, what? Like, yeah, like, it's interesting, but like, is this not meant to be like a production ready language? Like, how you can't just leave these interesting things in there that are clearly not good designs. Like, it's kind of unintentional, isn't it? If this succeeds, but all effects are thrown away, this is a way to try to see if the complex version will succeed. Sure, man. I wonder why it even throws them away. Maybe I missed something there. Expressions in decides. A subtle feature is how relational expressions behave in decides contexts. When comparison appears in a context that can handle failure, it is not just a condition, it produces a value. Huh? X more than 0 returns X, and 0 less than or equal to X returns 0. What? I thought this was just like a boolean. I didn't know it actually like returned a value. But like, that's not clear at all either. Like, that's so implicit. It's insane. Yeah, subtle feature. Yeah, but like in a bad way, bro. Like, this reads as X if X does not equal Y. X if X is less than equal to limit. Like, that's not. I don't like that, dude. Value and value. How does that work then? And because it circles to the left side. Yeah, like that's so weird to follow. I don't like that at all. There are option types. They're connected. False means empty, because they couldn't just add an empty keyword. Question mark converts between options and failure. What? So putting a question mark turns an optional value into a failure. Okay, the option constructor works in reverse, converting a failure to an empty option. Right. This bidirectional conversion makes options and failure interchangeable. Choose the most appropriate representation, dude. Okay. Verse has a rich and flexible syntax, which can sometimes cause subtle bugs. I thought we were moving away from C++, you know? A comma gives rise to a tuple in an option, whereas a semicolon evaluates all values but retain only the last one. Right, so that this comma versus this semicolon thing again. Why, bro? Again, like, why would I use this example? Like, it's just not even useful. Unwrapping extracts values from options, filling if the option is empty. Unwrapping is only allowed in failure context. So question mark unwraps, okay? Which is kind of funky. Nesting, helper functions, chained access. So there is question mark dot. Head next value fails if any link is empty. Right, so that's cool. I mean, that's like Rust, but like in a very roundabout way. Like, what the hell? Okay, man. Yeah. Like, why is it suffix in this case? It's suffix in the other cases, right? Yeah. Wait, what? Double question mark is double nested. Using the OR operator to provide fallback values for empty options. Primary or secondary or default. Huh. Okay, that is actually an interesting use case of the binary operators returning the first, the binary boolean operators returning the first value, right? Because then you can do this. You can do this or this or this, and it will return the first one that succeeds, right? No. Wait, what? No, never mind. That's not what it said it did. It said it said that if I have A if I have A opt B, it will return A. But here it can return C if that's the only one that is available. So actually no, that's not even related, I guess. Chaining comparison, sorry. Okay. You can't compare without unwrapping. Yeah. Fail with optionals. Okay. Casts as he sides. Castable. What? Class castable. So the cast, you can like wrap it in like a, yeah, constructor, almost, but because it can fail, it uses square brackets. That's so weird, dude. Yes, I'm gonna access the array or map physics component with comp. Oh, what? That's a cast? Ah, of course, yeah. Yeah, no, that was obvious by the syntax where, you know, it's the exact same. Okay. Like, for anyone who says, you know, it's cool because it's like succinct, that's not a cool thing, you know. Like, reading the code matters more than writing it. The cast itself is a condition, no separate type checker needed. When the cast succeeds, you both confirm the type and attains a properly typed reference, and you can chain casts. Okay. This can create self-documenting validation chains where type requirements are explicit. Man, this book is hard to read because the book itself forgets what it said like 2 paragraphs ago, so like it'll just like reintroduce a concept that it already introduced, as if it's new, and so like you look at it like, is something different about it this time? Like no, it's just dementia. This creates self-documenting validation chains where type requirements are explicit. Yeah. Caps work with the OR combinator for fallback types. I mean, this is interesting, right? Validation chains. I guess. Or you can just write that manually, but whatever. Caps work with the OR combinator for fallback types. Okay. So OR has 2 different uses here, like in this language, I guess. No, it just chooses the one that succeeds. And then if it succeeds in an if statement, then it's true, I guess. It just reads weirdly. Like, I get the idea, but if you can just make it read, like, better. Idioms and patterns, okay. Like we're just throwing things in a list, dude. So player is getting player, is valid turn player. Like have like an assert or something, or like an if return, you know, like just anything. To like help me understand the control flow. Instead, like I'm just calling a function and it's like, okay, square brackets, that's not an array, right? It's a function, and it's not a map. So therefore, this is a function call. Therefore, if this fails, it will return a fail. Okay. And it's like, yo. Like, I'm sure you can get used to it, but like, do I want to get used to it? With how, like, badly it reads? Each line must succeed for execution to continue. This creates self-documented code where preconditions are explicit and text in order. You know what else does? Like, you can do that in other languages. This is just a more messy syntax for it. The first success pattern tries alternatives until one works. Okay. This naturally expresses trying simple solutions before complex ones. The filtering pattern uses failure to select items. The filtering pattern. For enemies, level, get level, okay, so 1 enemy. At this point, I wouldn't mind having a filter function, where I just say filter enemies, where level equals get level enemy, and level is going to equal to 10. Or just get level enemy is going to equal to 10, you know? Like, I'd rather, like, it's cool that 4 can do this, but at that point, I kind of want to have, like, a way to define my own loop kind of functions. So I can say, filter with the first argument as the thing I'm filtering, right? The collection, let's say. I guess that's the term. And then the second argument would just be the condition. And that would just read a bit nicer than having like for enemy blah blah enemy, you know? Only enemies that have a level and whose level is at least 10 are included in the results. Either the trade succeeds or nothing changes. Optional indexing. Yeah. Okay. Runtime errors. So there is an error function. Why would you use runtime errors? Like, maybe it's good for debugging, but like otherwise, you don't want to have just random errors in your game, you know? Like, it's one thing for like a soft like an app to crash, like Discord, or a browser to crash with an error message or something. But for a game to crash with an error message that's like negative values are not allowed, like, no. You should never use, like, this is a really weird thing to include for a game engine language of all things. Like, have like a debug messages, like an error that just like literally causes a runtime crash. It's very strange. When a runtime error occurs, execution unwinds to the call stack, terminating the current operation. And then what happens? And they propagate through asynchronous operations. When a spawn task encounters runtime error, that specific task terminates. The runtime error does not automatically propagate to the spawn task. Like, I feel like it shouldn't even need this. Like, the whole point of effects, I feel like, is to catch these at compile time. Living with failure versus approach to live failure has reached simple logic programming. Ooh, okay, actually that's interesting. I haven't looked into logic-oriented programming that much. I wonder if that is what has inspired this paradigm. Like, I think Prolog is that, right? Is one such example. Yeah, Prolog. So let's have like a Prolog a bit later. Although, I'm not sure if it's like a good standard. Holy syntax highlighting. A language for AI. Literally. How do I see like Prolog guide? Okay, we'll have a look at that in a bit. Where a computation search for solutions rather than executing steps. When a path fails, the computation backtracks and tries alternatives. Okay, so that's why I've heard of this before. The non-deterministic module, while powerful, can be hard to reason about in its full generality. Verse tames this power by making failure context explicit and limiting backtracking to specific constructs. Okay. Consider a simple logic puzzle solver. If any constraint can't be satisfied, the entire attempt fails. In a full logic programming language, this might trigger complex backtracking. In verse, the failure model is simpler and more predictable while still expressive enough for most problems. But I thought I did have backtracking, no? Instead of thinking about error conditions that need to be avoided, think about success conditions that need to be met. Yeah, but like, again, you can do that. Anyway. But, okay. Instead of defensive, like, there are other ways to do this. Instead of defensive programming that checks everything before acting, write optimistic code that attempts operations and handles failure gracefully. Okay. I see. Thing is, I do like defensive programming. But then, if I want to have optimistic code, that I guess that's what you call the other thing, I would have conditions in the type system, not in the body of functions. You know, like, if I have requirements, I put them in like, somewhere like, somehow integrate that into the type system, so that calling a function with an invalid value is simply not possible, as opposed to having to, like, unwind the call stack and all of that, you know? Because then it moves things to compile time as well. And then you can write optimistic code. Well, not even optimistic code, like, just write code that is literally error-free, because the errors can't leak into the function in the first place, into the function body, because the value get caught at compile time. This perspective makes code more readable and intent more clear. It's true. Yeah, go on. When you see a function marked with decides, you know it represents a computation that might not have a result. Yeah, I mean, like, that's the effects. Dude, like, why is it... I feel like we should have started with the effect system at this point, with how much, like, it's referencing it. When you see expressions in a sequence within a failure context, you know they represent conditions that must all be met. Failure in a verse is not something to be feared or avoided, it is a tool to be embraced. It makes programs safer by eliminating certain categories of bugs. Not all, though. It makes, yeah, I mean, I guess it can't. It makes code clearer by unifying validation and action. It makes complex operations simpler by providing automatic rollback. It aligns the way we write programs with the way we think about actions and decisions in the real world. That's true, right? Like, if I tell someone, yo, go grab my wallet in the kitchen, right? If the kitchen doesn't exist, I don't need to tell you that, yo, if the kitchen exists and my wallet is on the table, go grab it for me and bring it back, will you? Like that's very confusing, right? If I just say, go get my wallet from the kitchen, right, then if the kitchen doesn't exist or the wallet isn't on the table, did I mention the table? But whatever. Then just come back with an error and say, yeah, it's not there. But like, yo, the kitchen's like there's no kitchen. What are you on about? And I'd be like, you're right. That's true. It's true. Further in the verse, okay. As you write more verse codes, you'll find that failure becomes second nature. You'll reach for failable expressions naturally when expressing conditions. Well, obviously, you don't really have a choice, do you? You'll structure your functions to fail early when preconditions are not met. You'll compose failures to create sophisticated control flow without necessary conditionals, and you'll appreciate how this different way of thinking about control flow leads to code that is both more robust and more expressive than traditional approaches. But how about modern approaches? How about that? Okay. Structs and enums. So, verse as a value-oriented type system, what does that mean? Providing lightweight alternatives to classes for simple data aggregation and fixed sets of named values. Unlike classes with their object-oriented features, structs and enums focus on simplicity, immutability, and value semantics. Structs bundle related data without methods or inheritance. It's fine. Perfect for mathematical types, configuration data, and simple records. Is it fine, actually? Like when would you not? Like, I feel like any type could benefit from having some kind of method attached to it, even like if that method is toString. Enums define fixed sets of named constants, replacing magic numbers with meaningful names. Yeah. Dude. Together, structs and enums complement classes and interfaces by offering simpler, more constrained type constructors optimized for specific use cases. Why don't I even read the summary if it's going to just repeat the same thing, you know, like, I don't... Damage type equals enum. I mean, like, it shouldn't even be a summary, it should be an introduction. Structs group related data with minimal overhead. Yeah. Like, say like a vector, you know? Like, what if I wanted to find, like, you know, add and subtract operations for it? Like, do I just overload the operator? Like, a trait system would be a lot nicer. All struct fields are public and immutable by default. They cannot have methods, constructors, or participate in inheritance hierarchies. It makes them efficient, but like, could they not have just had like classes and then had structs be like an effect? Or something along those lines. Creating struct instances uses the same archetype syntax as classes. Okay? As if I've read the classes section yet, but since structs are value types, assigning a struct to a variable because of copy false data. Alright. Okay. Enums. Yeah. Can I have tagged unions? You cannot use the enum type where value is expected. Why would I... Again, dude, so many things in this book are examples of things I wouldn't even think of trying because it makes no sense. And they're like, by the way, you can't do this. And it's like, really? Like, it's like giving like a tutorial on how to drive a car and saying, by the way, the car can't fly, so don't even try. And it's like, was I meant to, like, did you imply earlier that it might be able to fly? Like it just confuses, and it's like, did I miss something? Is what I wonder, and then like that's distracting and like makes me think about earlier things when there's nothing there. So like, it's not like it's like a harmless, oh by the way, like no, like it makes no sense. Like you're just wasting my time. You cannot use the enum type where a value is expected. This distinction prevents confusion and ensures type safety. What does that mean, bro? Am I missing something? In use with a type and a set of values, yeah? Dude, you can't do this like in C++, you can't do this in C either, it's like, who? Where? Who's asking, like, is there a language where you can use the type as the value? Am I missing something? Like like if the type is the type, why would I assign the type? That's like saying, you know, foo of type int equals int. Like, what? It doesn't make sense. This distinction prevents confusion, and ensures type safety. The enum type defines what values are possible, while enum values are the actual constants used in your code. Who would think this? It's just making assumptions that no one would make in their right mind. Like, even if someone, for God knows what reason, thought this, you know, as possible, because I guess they just don't follow, like, simple logic. Why would you even entertain that? You know, don't what's the word? Don't, like, validate them, because it doesn't make sense. Restrictions, you don't have specific, like, the last thing I want is for someone to read this and go, ah, yeah, you know, I was thinking it might. Like, why? Why were you thinking that? Don't think that. Enums have specific syntax requirements that keep their usage clear and unambiguous. Enums must be direct right-hand other definitions. Let's see if any of these restrictions are actually restrictions. Enums must be direct right-hand side of definitions. That's just confusing, dude. Like, this rule is misguided, you know? The rule isn't that it must be a direct right-hand side of definitions. No, the rule is that I can't have a negative enum. And I can't have an enum plus 1, because that's not a right-hand rule, it's a type error. This documentation is actually, like, this might be the worst documented language made by, like, a legitimate organization that I've read so far. Because what in the world, bro? Why? Not only is it pointing out something that, again, I wouldn't even think to try, because it doesn't make sense, but it's also, like, giving it a rule, and, like, pretending it's, like, some other rule. Like, no, it's a type error. It's clearly a type error. Like, you're just making it harder to learn. Because now someone will read this and be like, oh, wait, so there's a rule I have to remember? I can't use it on the direct right-hand side definitions. You know, and hopefully they would say, oh, but, like, I can't do that anyway. But, you know, there'll be some poor soul out there who's like, damn, there's so many rules I have to remember now. I can't have a negative enum, okay. I can't plus 1, okay. I mean, I guess. Like, no. Just no. Enums must be module or class level definitions. No local enums. Also, is this a definition? Is this an enum definition? This just makes even less sense now. Why would that be there, bro? Why would that doesn't make sense? You know, and, like, why not? Like, why can't I use an enum in an expression to make, like, a union, you know? That'd be cool. Like, it's put enum xy plus enum ab. That would make more sense, you know, to say, by the way, you can't do that. But to say plus 1, and, like, it doesn't even include the other one, unless you can add enums. But I assume you can't. It is weird though that you can't put them locally. Like, why not? Stable referenceable definitions that your code base. Like, why? I mean, like, I've never wanted to define one locally, but, like, why, of all the things to restrict, why restrict that, you know? I gotta share this, bro. Oh yeah, I noticed that the recording yesterday, or I guess today's recording, because, well, the video I recorded yesterday, the quality's really bad. Like, really bad. And I don't know if it's because of my monitor, or if, like, my OBS is, recording on lower quality than I thought. Like, it should be 720p, but like the quality is abysmal. But maybe it's just because my screen's really small. I realize it means that like it's hard to read the page, so I might zoom in a bit. But yeah, that's unfortunate. Okay, using enums, yeah. So there's enum close and open. Yeah, so, okay, so it tells you that you can't add more. Enums can be marked as open or closed. It's closed by default. Why would you mark it explicitly as closed then? Fundamentally affecting how they can evolve and how they interact with pattern matching. Right, so closed enums commit to a fixed set of values forever. This allows the compiler to verify that case expressions handle all possibilities exhaustively. See, I don't like that. I'd prefer just having, like, rather than that being on the type level, I prefer if it was in my usage level. Like, if, like, I want a way to differentiate between having an exhaustive pattern match and a non-exhaustive pattern match, rather than it being part of the type. Because like there are certainly cases where I want to exhaustively match in one case and then not in another case, right? Without having to do like underscore thing is nothing, whatever, or just do that. I mean that also works, doesn't it? That also works, doesn't it? But he says open enums cannot be exhaustive since future values might exist. Yeah, but the whole point is that like pattern matching solves this by being exhaustive. It means that if I add a new type, then it catches it. Like that's the whole point. Like this is so dumb as well. Inheritance. sometimes useful. Is that even a use case? I don't know. Hey, whoops. Zoom in here. Right. Exhaustiveness. Sophisticated rules. Close enums with full coverage. Like, what I'm wondering is who these docs for? Like, are they for new programmers? Are they for C programmers? Like, I don't really understand. Because, like, so many things are not only explained, you know, as if... Like, not only are some things explained, like, as if you have no prior knowledge of programming, and that also, like, as if you do have some prior knowledge of some language, but also, like, some things are just explained so badly. When your case expression handles every value in a closed enum, no wildcard is needed. Adding wildcard when all cases are covered triggers an unreachable code warning. Warning, unreachable, all values already matched. Aww. It's a closed enum. So you're saying that more won't be added later. That's so dumb though. Like, I don't want it to be, like, you shouldn't really have a closed enum because you don't know if you're going to add new ones in the future or not. Like, making promises early on to, like, restrict your future proofing and having that be the default no less is really bad. It's actually really bad because then it means that you have people, like, you know, will think, oh yeah, I don't need to change that later, and then they will need to change it later because you can't possibly predict the future, and then you're screwed. You're screwed because the whole architecture was, like, built on the promise that things wouldn't change. So then you're like, I deprecate that, I make a new type, and then you get C++ all over again. Like, dude, it's like watching not the Mona Lisa being painted. It's like that, but like a bad thing, you know? It's like watching... It's like watching someone kill Frank Ferdinand for the second time. Yeah. Adding a wildcard when all cases are covered... Like, that's so annoying too, that, like, it triggers an unreachable warning. Like, was it worth it just for this warning? Close enums with partial coverage. If you don't match all values, you must either provide a wildcard or be in an initialized context. Like, I would do this to say, like, if a new one is added, I don't care, you know? But, oh, it's closed, so, like, it doesn't matter. But, like, what if it changes to open? You know, like, that can happen, by the way. I can just change the enum signature to be open instead. And then, whoops, like, now this is just, like, just implicitly... Implicit! Man! If you do not match all values, you must either provide a when was this language made? Like, when did it start production? Because, like, some of these things are so backwards to what is, like, now regarded as good practice. This is very strange. Missing other days causes failure. Seriously? So it's not an error. It's not a compile error. It causes failure. What if I don't want, like, can I have, like, a block that doesn't have the sides? Do you know how annoying this is? Like, am I crazy? Am I crazy, or, like, is this literally gonna be a real problem for people writing control flow? Because of, like, how the failure system, like, wants everything to possibly fail, including things that really don't need to. Open enums always require a wildcard or decides. Oh, okay. No, okay, yeah. That's obvious. Summary of exhaustive rules. Why are there so many rules? Like, why would you make someone look at this table as if they're meant to memorize it? You wouldn't memorize this. Just use the logical rules, which are that if I do this, and like, what you do as well is when you create a rule table, you focus on these individual rules as opposed to thinking, how can I make these rules intuitive and natural? No, instead you just create the rules and say, Yeah, follow these rules. Like, that's not how you should do it. Having clear documentation that doesn't require a table like this, and instead, where the user can just understand it because it makes sense. That's the sign of a language that makes sense. If you need to create a table like this to express your language's rules, I believe you have a problem, because suddenly it's not like easy, or like it's not intuitive, or like consistent. Like it just feels like a bunch of arbitrary rules thrown together. Ugh. Like a product actively detects unreachable cases in some in-case expressions, helping you identify dead codes and logic errors. Duplicate cases are flagged as unreachable. Yeah, that's fine. Cases after wildcards are always unreachable. Yep. These errors prevent logic bugs within your handling specific cases the code will never execute. Yep, it's nice to prevent logic errors. They ignore unreachable attributes. Sometimes you intentionally want unreachable cases. This language has attributes. This is the first time I'm seeing an attribute. Why? Okay, another issue. Some words of wisdom. If you need an attribute for a feature, especially like when you already have an effect system, something ain't right. Sometimes you intentionally want unreachable cases for testing, migration, or defensive programming. The ignore unreachable attributes expresses unreachable warnings and errors for specific cases. For testing, migration, or defensive programming. Is there a use case for this? There must be, but like, or I assume there is, but like what? What is so special about this? Like, what is so useful about this? Surely this is obviously just a bad example. Another issue with this book is that the examples it uses for features that like are really niche and like supposedly useful, is that it doesn't use useful examples. So like I have no idea why this would be useful. It just leaves more questions than not, and then I probably just forget about this anyway because I'm like, okay, I don't care. Like why would I ever need to do this when I can't just comment it out? I don't understand. Obviously, using it sparingly. Why even have it? During refactoring or maintaining multiple code paths for testing purposes. Commenting out? Surely? Refactoring? Why would you have this during refactoring either? I don't understand. Like, what refactoring process would you have to be going through to do that, of all things? Is that 36? Is that 36 commits or 36 files? Enumerators can. Let me actually have a look at some of these issues real quick. I'm almost done though. Enumerators can collide with identifiers and parent scopes. When this happens, you can use explicit qualification to disambiguate. What? Disambiguate from what? The whole point of this is that it's namespaced. Yeah, I could rant about this to hell and back, man. Can enums contain data, by the way? I thought that it could, but I'm not seeing it here now. but it's not actually a recursive enum. Bro, I don't understand this. This is so stupid for no reason. Even not though, like, start using a type. Classes and interfaces are versus object-oriented building blocks. Classes provide single interfaces with fields and methods. Okay. Single inheritance. But there are interfaces, right? Okay. The constructor is done through a block clause. Who designed this? I've gone from like, this is promising, you know? It's got people from Haskell, from Java, to now being like, who? This looks like someone just went like, you know what, guys? I don't know. Let's just use block, you know? What the hell? There are multiple. You can have multiple. What? I don't understand it. I actually don't understand. They cannot contain failure. Why not? Have it fail on construction. Blocks cannot cause suspending suspends functions. Block could use the first statements which execute the block exits. Block clauses are only allowed in classes or inherent interfaces, structures, and modules. Kill me, bro. Let clauses in archetypes. And like, it's not really a good structure because you can't feed it values. It just... so strange, dude. Let clauses in archetypes. Archetype expressions can include let clauses that introduce local variable bindings. These are useful for computing intermediate values. What? Is there a lesson set in this language? Hold on. How do I define a variable? No. So this is the first time we're seeing let, right? Wait, what? Constructor? Did I miss something? No. What's this? MK word 8 constructor. Int. What is that? What is that? Dude. So it's like Haskell where, but like just reversed. Why? Archetype express. Surely, like, is that explained later? Archetype expressions. What is this? Can include let clauses that introduce local variable bindings. B equals 0, less than or equal to I, and I... Oh my god. Such a weird way to do it, dude. Why not just have it be in line as like a normal expression? Like I don't understand that. Like it already has failable things, so like just have that be a thing, you know? Self, okay, the current instance. Yeah. Classes support single inheritance. Superclass, method overloading. Constructor functions. Like why did it introduce let clauses before introducing the actual archetypes? I don't understand. Classes do not have traditional constructor methods like you might find in object. Yeah. So, archetype expressions, direct field initialization for simple cases, straightforward and requires no extra definitions. Unless you want to, of course, using let. Block clauses, we saw that already, and constructor functions annotated with constructor. These are first class functions that can validate inputs, delegate to other constructors, be overloaded, and be passed around as values. What? We need validation or computation, yeah. That's cool. So it's not even part of the function? Like it's not even like a static method. It's just like a floating function. Oh my god. It is the same mistake that Odin and Nim does, dude. If I want to make a player, I want it to belong to the player class, not have some like global function called make player. Cause like it's redundant, dude. Like does no one think about these things? I'm mad, bro. I'm mad now. You can overload them, which is, yeah, good, I guess. Delegating constructors. Okay, shadowing clarification. You know what, I don't really care anymore, dude. Generic classes, awesome. Attributes. Okay. So there's public, private, and protected, and internal. Okay. I don't really understand the whole internal thing, but yeah, like for debugging. Fair enough. Concrete specifier enforces that all fields have default values, allowing construction with an empty archetype. Why does that need to be an explicit effect? Like, if like the reason you would have effects, from my understanding, is to make the compiler's life easier. So like every time it checks like the function, it doesn't need to like validate it itself manually. But like for this example, like why? What's the use here? Like I wish it would explain the use for each one, you know. Also, like it uses the same syntax as effects. Which makes you wonder, like, do effects even need to have a special syntax, or are they basically just modifiers, right? Like, they're basically just modifiers, aren't they? Like attributes, modifiers, effects, like they're all the same thing. It's just different syntax, and you can pick and choose. Like mutable, you know, mute is an effect, in a way. The unique specifier creates classes and interfaces with reference semantics, where each instance has a distinct identity. Right, I saw this, yeah. Whatever. Abstract. They cannot be instantiated directly. Yeah, that's pretty cool. Again, in other languages, that's just a modifier. So you say abstract class. Having it be like this is interesting. Keep in mind, I guess. Castable? Castable subtype. Right. Fallible and infallible casts. Now it has fallible and infallible instead of failable. So finally, it just switched to the actual English term now for some reason. Okay, final. Yeah. Persistible. Okay. Interfaces. Okay. Type system. Oh my days, bro. There's any and there's false. Subtyping is validation of the type hierarchy. Is it? Because it only mentioned it now. as if the type system isn't like one of the most important things in the language. I mean, like, it has hinted at subtyping, but I mean, like, as like a core, like, foundational feature. Okay, conversions. Edge cases. Void? Discard type. Well, yeah, there is a void type. What a weird way to have void. Like, this might be like also a really weird like implementation or design of an expression-oriented language. Like, it refuses to have a unit type, so it instead goes for a void, which just discards the value. But then what? That's still failable, right? Yeah. So weird, dude. Like, what a weird way to design it. Aliases, metatypes, don't care. Okay. Access specifiers, public, internal, yeah, we can't really store those. Epic internal. For verse. Only usable by epic authored code. Okay, bro. Scoped. So what scope, sorry? Current scope and closing spaces. There are annotations, which are different from the other, I don't know, other specifiers. Deprecated makes sense as an annotation. I like deprecated. Because that's like, you know, yeah, it's good. What else we got? Experimental? Ooh. Oh, okay, it's an internal feature. So ironically, experimental is somewhat experimental. Pink hoodie. Okay. Okay. Available controls when a definition becomes available based on version numbers. Available 3000. That's weird. It means like overload things, right? Oh no, okay, no, I understand. I think, yeah, like the C++ standard library does the same thing. it checks what the compiler version is, or what the standard, what standard you're compiling with, and then it has those in if-defs, or something along those lines. Okay, it'd be cool if you could have like an available. I mean, actually, same for all of these. If you could have like a scope, as well, so like rather than like taking them individually, you could have like a whole almost like a namespace kind of thing, but there are custom attributes, but they're internal, so they're not really custom, but okay. Yeah, I have mixed feelings on custom attributes. I mean, mixed, I mean, I don't like them. Like, gameplay elements, weapon system. Like, why would I tag it as opposed to just creating a gameplay element object, you know, that contains a weapon system or something, or like some kind of like lookup table. Like I don't like this. Serializable field, serialization key equals entity ID, ID int. Like, why not just make a different, rather than have this, why not wrap it in a type? Even if it's like a serializable field type, and then say like the field equals ID int and then that, you know? I don't know. I gotta experiment more with that. There's also getter and setter accessors. Oh, really? What? But there are live variables. Which I guess aren't setters, but like, this is a very weird way, like, yeah, this is a really bad way of implementing it. Like it works, but it's just so, this doesn't innovate on existing syntax at all. Like it's worse than C#. Like why would you do this when C# already offers a pretty decent way? Like at least improve on that. Don't make something worse. Which is why again I'm wondering how long ago was this language designed? Because like this seems like the product of like development hell. When was Verslang started? 2020. Are you dead ass? Localizes. How's that work? Message type. Okay. That makes sense for a game engine. Having it built in as like a convenient feature. Yeah, sure, why not? Although it is a bit weird that it's done this way. Message parameters, a lot of times just can accept parameters, for example, like content interpolation. Sure. Yeah, sure. Evolution. Okay, right, finally, effects. And okay, every function tells two stories. The first story, told through types, describes what data flows in and what data flows out. The second story, told through effects, describes what the function does along the way. whether it reads from memory, writes to storage, might fail, or could suspend execution. 2 stories? Where, like, every function tells 2 stories. The first story told through types, the second story told through effects. It's like, why? Or maybe they just tell different parts of the same story. Whether it reads from memory, while most languages leave the second story implicit, verse makes it explicit, turning side effects from hidden surprises into documented contracts. Sure. So think about a simple game function that updates the player's score. In most languages, you see a signature like update score, and have to guess what happens inside it. Does it modify the player object, write to a database, print to a blog, trigger animations? Without reading the implementation, you can't know. Inverse effects are part of the signature itself. Yeah. This explicitness might seem like extra work at first, but it fundamentally changes how you reason about code. When you see reason a function, you know it observes mutable state. When you see writes, blah 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 blah. Yeah, but it helps the compiler, which is the important thing to note. Effects represent observable interactions between your code and the world around it. Reading a player's health, updating a score, spotting a particle effect, waiting for an animation to complete, bleep, 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 blah, blah. The transacts effect tells you immediately that this function modifies mutable state. Code greeting is a global variable, right? You do not need to read the implementation to know that calling greet play will change something in your program's memory. The effect is a promise about behavior, checked and enforced by the compiler. Yeah. Wouldn't it be interesting if, like, you specified which variables were mutated in the effect as well? Like transacts current greeting, for instance. That'd be pretty interesting. Perhaps. Like, at what point is it too explicit or too verbose? The effect is a promise about behavior, checked, yeah. Effects compose naturally through function calls. If function A calls function B, and B has certain effects, and A must declare at least those same effects. But there are some exceptions. This propagation ensures that effects can be hidden or laundered through intermediate functions. Yeah. Why they matter. Making effects explicit serves both human understanding and compiler optimization. Thank you. For developers, effects act as documentation that can't lie. When you are debugging why a value changes unexpectedly, you can trace through the call chain looking only at functions with writes. True. When you're trying to understand why a function might fail, you look for decides. For the compiler, explicit effects enable powerful optimizations and safety guarantees. Pure functions marked compute can be memoized. Yeah, the results cached because it'll always return the same output for the same input. Functions without writes can be safely executed in parallel without locks. Concurrency. Functions without decides can be called without failure handling. The effect system also enforces architectural decisions. Want to ensure your math library remains pure? Markers functions computes. Building a predictive client system must run on place machines. Use predicts to ensure no server-only operations sneak in. Okay, I don't know about that. These are not just conventions, they're compiler-enforced guarantees. Yeah, cool. Effect families and specifiers. First, organizes effects into families, okay? Each family contains fundamental effects, and effect specifiers declare which effects a function may perform. So there's cardinality, whether and how a function returns, heap, for mutual memory, a bit of a weird name for that, suspension, whether a function may suspend, I mean, I guess they would be on the heap, well, what if it mutates one of the function arguments? Suspension, whether a function may suspend execution, divergence, run forever, prediction, whether it runs. What? What does that mean? Internal, reserved for internal use. Okay. Some effects have no specifier, while some specifiers may imply multiple effects. Ah, yeah. For instance, transacts implies reads, writes, and allocates, and belongs to the heap family. Effect specifiers can be further divided into exclusive specifiers, converges, computes, transacts, and additive specifiers. What does that mean? Suspends, decides, reads, writes, allocates. A function may have at most one exclusive specifier, but can combine multiple additive ones. For example, computes decides is valid, but computes transacts is an error, cannot have two exclusive effects. It's weird actually. Having computes as an effect is weird. Yeah. Cause like if it's impure, wouldn't you want that to be documented instead? Like, I get, like, maybe it's a hassle to do that, but it means that you don't need these exclusive specifiers. It means that you just have an additive system instead, right? So, sorry, computes, converges, I think means doesn't finish, right? Yeah, I don't know. That's the smell to me. Fundamentally succeeds. Okay, that's just by default, I guess. Decides. Implies succeeds and fails. Okay. Oh, okay, so okay. Cannot combine with suspends. Okay. Reads. Writes. Allocates. Allows allocation of mutable memory. Mutable, but only mutable. Transacts. Exclusive default. Reads, writes, allocates. So it transacts by default. So why would I specify it then? That's weird. Computes. Suspends. Can I combine with decides? Divergence. Yeah, but what does it do? Exclusive native functions. Okay. Prediction. Dictates. That's this one. Oh, these are effects and these are specifiers. Yeah. Sorry, it's just weird that like there's overlap on that. No rollback. To be deprecated. Okay. How they compose. Think of effect specifiers as setting bits in a bit vector. 1 bit per fundamental effect. Without any annotation, a function such as getUpdate has the following effects. Dictates, does not suspend, it reads, it writes, it allocates, it succeeds, it does not fail. It cannot fail. Sure. A bit vector, sure. Why would I... Well, I'm sorry, like, why would I think about it setting bits in a bit vector unless that's literally what it's doing? Like, I feel like that's not an abstraction I as a human would want to make. A specifier like fails means the function always fails. Who decided that? Anticipating a function only affects the bits in the specifier's family. For example, function... Yeah. But this analogy is so bad. Dictates, suspends... Okay, so if I put reason predicts, it affects these. Okay. Affect families in detail, cardinality effects. Okay. Okay. Sorry, the order just messed me up. When the function is returned value successfully, every function either succeeds or fails. Heap effects. Given the same inputs, they always produce the same outputs. The rights of effect permit modification in mutable state. Functions with this effect can use set to update variables in mutable fields. Okay. In fact, the set instruction is by default transacts due to the addition of live variables to the language. A live variable is a variable whose divided as another variable, yeah. Weird. Yeah, it uses effects in a very like in-engine practical way. if another language like C++ or Rust were to add effects, I imagine that they'd be quite different. Because you'd want to know things like allocates, but like literally like does it allocate memory to the heap, like straight up, or like a thing like I don't know. Succession effects, okay. Additional effects. Okay. Where code runs in a client-server architecture. Predicts allows functions to run predictively on clients for responsiveness, with the server later validating and potentially correcting the results. Are Unreal Engine games, do they have to be server-based? They don't, right? They don't have to be live servers. But okay, again, makes sense specifically for the game engine. Specifically for the game engine. Oh, converges means a finishing infinite time. Composition. Subtyping. Data types. Okay, for the constructors, okay. Concurrency. Yeah, okay. That was pretty underwhelming, to be honest. Let me look at Coca. A language like has effects, but like properly, you know. That's what I want to see. Control time flow as naturally as your control program flow. Unlike traditional programming languages that bolt on concurrency as an afterthought, it's true. Verse integrates the time flow control directly into the language through dedicated expressions and effects. Yeah, especially for game development, right? So there are immediate and async expressions. Every expression falls into one of two categories, immediate or async. Understanding this distinction is crucial, yeah. Immediate expressions arrive with no delay. Async, on the other hand, have the possibility of taking time to evaluate, potentially spanning multiple simulation updates. They represent operations that inherently take time in the game world, like animations. Oh yeah, animations playing out. I didn't really thought about that. That'd be quite interesting actually. Like even in my game engine for C++, the way I do animations isn't just like an update loop kind of thing, and even with like when I was making a game in Unity, I was having so much issue like sorting out the animations for these 3D models, like having them switch properly was actually really difficult. But with concurrency instead of using like a manual like for like like an update loop with like flags to match like is animation finished and all that kind of thing, if I use concurrency instead, that'll probably make things a lot easier. So that's actually good to think about. Yeah, let me finally take a note of this again. This is concurrency. Core concepts. Immediate versus what? Async expressions. Yeah. I was really struggling to implement an animation and timing, or animation and timing systems for Shin SVZ, which is my fan game for this game thing, don't worry about it, in Unity. And I wonder if I could have used async programming, or like async style programming instead, to make things a lot easier. You know, at the cost of learning a new paradigm, but obviously worth it. An async expression might complete immediately if its conditions are already met, or it might suspend execution, allowing other code to run while it waits for the right moment to resume. A simulation update, or tick, represents one step of the game simulation. Simulation and rendering are independent. They run at separate rates and are decoupled from each other in modern engines. Really? Okay. In my engine, they are in the same loop. So that's interesting. Maybe I could make my game engine concurrent instead then. Like design it so that rather than having update loops, I have like just inherent concurrent systems using like effects. Events, like an event-based system. That'd be quite interesting. But then have like, you know, the rendering would be its own loop. Each tick processes input, updates game logic, runs. Hold on. Simulation updates. Yeah, I wonder if I could, I should design my game engine to also to use event-based programming rather than update loops. Right now, I do have my game logic and rendering happen in the same loop, but this could easily be decoupled even with how it's designed currently. I mean, easily, you know, as in like from a architectural standpoint, each tick processes input, updates game logic, runs physics, and advances the game state. Versus concurrency model lets you think in terms of logical time flow. Async expressions suspend at tick boundaries and resume in future ticks when their conditions are met. Async expressions naturally align with this update value cycle. When an async expression suspends, it yields control back to the game engine, which continues processing other tasks and rendering frames. The suspended expression resumes in a future update when its conditions are met, seamlessly continuing from where it left off. Oh, so this is, okay, yeah, suspense effect. With suspends, functions marked with suspends can use concurrency expressions, call other suspending functions, and cooperatively yield execution. Sleep. That's nice. Just being sleep. Like standard thread. Sleep for duration. Is that a thing actually? Standard thread sleep. Huh. Standard this thread sleep for? Is that actually what it is? That's so funny. Structured concurrency. Structured concurrency represents one of Verse's most elegant design decisions. Rather than supporting threads or tasks that live independently and require manual lifecycle management, structured concurrency expressions have lifespans naturally bound to their enclosing scope. When you enter a structured concurrency block, you know that all concurrent operations within will be properly managed and cleaned up when the block exits. Let's see. This approach mirrors how we think about sequential code. Just as a block of sequential code statements has a clear beginning and end, structured concurrent. Yeah, so there's a sync scope, an erase scope, rush, and branch. Okay. I like this. The sync expression embodies the simplest concurrent pattern, doing multiple things at once and waiting for all of them to finish. When you have independent operations that can benefit from parallel execution, sync provides a clean way to express its parallelism while maintaining deterministic behavior. Yeah, that's cool. Like, it makes it so easy. I think there is great potential for both async-oriented programming and FX systems hand in hand. Like, imagine like if in C++, I could just do rather than doing like standard SIMD or whatever. Oh well, I mean SIMD is different though because like it has like other requirements, but yeah, whatever. So instead of sync block, all expressions begin execution at essentially the same moment. The sync expression then waits patiently for every single subexpression to complete, regardless of how long each takes individually. Yeah. The beauty of sync lies in its predictability. You always get results from all subexpressions, always in the same order you wrote them. Packaged neatly in a tuple. Oh, so it returns a tuple, okay. So it's kind of like a function in that sense. This makes sync perfect for scenarios where you need multiple... You could probably do this, right? Like, I feel like you could wrap this in C++ or Rust. Maybe? This makes sync... I mean, I hope so, because I want to try that. This makes sync perfect for scenarios in my game engine in C++. This makes sync perfect for scenarios where you need multiple pieces of data or need to ensure multiple systems are ready before proceeding. Loading game assets in parallel, initializing, yeah, okay. So you got sync, block. What is block? Oh, it's just block, right. Load texture, then apply texture. Load sound, then play sound. Load model. Using sync results directly as function arguments. Cool. Then there's race. Race is the first one gets chosen, right? Yeah. And that's cool, actually. Yeah. Like, give the, like, yeah. The main one that comes to mind for me is like a timer. So like, let's say like for God of War, right? I have a, what do you call it? A something event, like a timed event or whatever, like where you have to press the input before the time expires, or else you get murked. Having that with a race makes perfect sense, you know. Whereas like the way that I would have done it in the past is literally write a for loop, or no, not a for loop, like a while loop with like a timer and like do that manually, and that's just so much more effort and boilerplate than just saying race 5 seconds or do this, you know. It's awesome. Imagine creating what's supposed to be, yeah, blah, 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 okay. Cancellation of race is immediate and thorough. The moment the winner emerges, all losing receive a cancellation signal. Result type. The most common super type of all these subexpressions. Okay, so it could be any. Yeah, that makes sense. A pattern involves adding identifiers to determine which one. Okay, then it's rush. The rush expression occupies a unique middle ground between sync and race. Like race, it completes as soon as the first subexpression finishes. Unlike race, it does not cancel the losers. So they keep working. But I'm guessing those would have to be for void functions. Rush shines in scenarios where you want to be responsive while still completing all operations eventually. So begin gameplay as soon as the current level loads, while continuing to cache the other levels in the background. Or think about achievements checking, where you want to notify the player as soon as one achievement unlocks while continuing to check for others. But what if, like with this current level load thing, what if it doesn't load first, right? Like I want to have some kind of way to say, start loading all of these, but as soon as this one finishes, proceed, you know? The non-cancellation nature of rush requires careful consideration. Those background tasks continue consuming resources and performing their operations even after rush completes. Yeah. But it's dangerous. Yeah, I feel like there's a safer way to make something like this, which is specify which one triggers, you know? There's an important technical restriction to be aware of, or like have like some other way to construct that without like an independent expression. Like, I don't know, how would you do that? Yeah, I'm not sure. There's an important technical restriction to be aware of. Rush cannot be used directly in the body of instruction expressions. Okay. Yeah, so that was a bit weird. A return statement inside a sync where a rush arm causes the enclosing function to return, not just the arm. Where? Whatever. The branch expression represents fire and forget concurrency within a structured context. When you counter a branch, it immediately starts executing its body. Oh, sorry. I know how you could do this without this. Just have a flag. So like when the background thing finishes loading, it will set a certain flag to true, and then it will move on with the task. So you put it in a sync block instead. No, not sync block. You put it in a yeah. No. A race expression, I guess? Will that work? No, it can't be race. What would it be? Okay, actually, I don't know. Never mind. The branch expression represents fire and forget concurrency, yeah. It starts executing its body as a background task, and then, without any pause or hesitation, continues with the next expression. Okay. Yeah, so then, here then, I can use branch to have, again, for like the level loading. So then like just say like, so like first branch, and then do a race expression afterwards. Ooh, hold on. Nah, it's simpler than that, isn't it? Just branch all the other tasks, and then after that run the lowest level thing. So then once the low level finishes, that finishes, and then it continues like normal. Then these ones are loading in the background. There you go, boom, done. So then, yeah, like, do you need rush? Because that's very simple with branch. Think about triggering particle effects that play out over time, starting background music that fades in gradually, or preloading assets that might be needed soon. They need to happen, but there's no reason to make them blah 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 blah. Customers' behavior. Okay, yeah. Spawn expression is versus what? Sorry, that was structured concurrency, and there's unstructured concurrency. This is so cool, man. Like, it changes the way you, like I said before, think about, like, Scratch. I've never liked Scratch to actually teach programming because it doesn't reflect actual languages. Like, if you learn Scratch, then, like, try to learn Python or C++, you're gonna struggle because, like, it like, so many things are different. Like, the control flow is completely different because Scratch uses asynchronous event-based programming, whereas Python and other languages are, for the most part, sequential, unless you opt in to the async features, but those features aren't easy to use anyway. Variables don't even like really exist in Scratch. Like you only have global variables, which you have to predefine. You can't like just make them on the fly without using like a whole list system. So that's also like really unintuitive. But even despite that, I don't dislike Scratch itself for how it works. I mean, it's very limited, but like if you use Penguin mod instead, which adds way more features, so like it's a lot more usable, like having variables and stuff like that, then it's actually very compelling. And nicer, like, yeah, it can feel nicer to use than traditional programming languages. Especially for like game development, where like you want things to be concurrent, you know. So that's cool. It's really cool. I wonder why more languages have like looked into this, looked into like this asynchronous programming. Maybe effect systems will be what finally makes it more, I don't know, seem more feasible to people who design these. And I wonder what Rust will do. Think of Spawn as an emergency escape hatch. Yep. No. Is Spawn like making a thread? I mean, like thread group, kind of, thread pool maybe? Allowing you to start an async operation that lives independently of its creating scope. Think of Spawn as an emergency escape hatch. Like what? What makes Spawn unique is the ability to work anywhere. Unlike all the structured concurrency expressions that require an async context, Spawn works in immediate functions, class constructors, blah 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 blah. Huh. What's like a good like use case for that? It's kind of like if you have multiple. I mean, I'm gonna like use like a lot of Scratch analogies. Hopefully, I mean Scratch is fairly common, right? It's like having multiple when green flag clicks blocks, right? Like each of those are completely independent of anything but the green flag being pressed, right? So like they're completely independent of the other blocks. They just run concurrently until they finish. It's kind of like that, I guess. Or like broadcasting a message, I guess, as well can happen. Although that can be overridden, because I believe calling the same message will interrupt the first one, at least in vanilla Scratch. Scratch is so specific anyway, but whatever. Yeah, I wonder why you would use Spawn. Like, if I want to launch like a separate application, but like, if I want to launch some process that's truly independent of the one who launched it, right? So like even like with the when green flag clicked, like the green flag being clicked still ties it to that application. But let's say I want to also launch like a settings menu that can outlive the application being closed or not, the game being closed. I mean, maybe there's limitations to that, but like something to that effect, right? Then I could use a spawn, because then like it owns its own thing. Kinda. Global backend services and monitor game states. Ah, yeah, okay. Yeah, and like debuggers type things. Cleanup tasks that must complete even if the triggering context ends, or integration points where immediate code needs to trigger async operations. Yeah, okay. Branch gives you structured fire and forgets, but its tasks are cancelled when the closing scope exits. Oh, wait, what? Sorry, I missed that detail. Oh. Yeah, so spawn is actually very clear then. And you can spawn multiple, right? Here it shows one for some reason, but I assume you can. It returns a task T, okay. Oh, that's like async await in C sharp, I think, where T is the return type of the spawn function. This task object provides methods to control and create the spawn operation. You can cancel it and wait for it to complete or check its current state. While spawn creates independent tasks that do not require management, having access to the task object uses the power to intervene when needed. Okay. Oh, look, there you go. The task T type represents a handle to an executing async operation. Right. I guess it's kind of like, I don't know, analogous to stack local variables versus heap allocated variables, right? I mean, I guess that's basically what it is. And the handle, the task handle, is like the pointer to the heap. And I only make that connection because I wonder then if you can not make it so raw. Like right now, spawn looks like a new, like in C++, right? Like the new keyword, or malloc in C. But these days, we tend to not be, well, we're advised not to use that. We should instead use some kind of wrapper like unique pointer, or if you're in Rust, there's like box, right? I wonder if something similar can apply to this. Like, but like, would you care about like thread ownership as well? Like would you have a unique thread handle or unique task, sorry, and like shared task? You could do with semantics there. But yeah, that's actually very very interesting. Because now, like, not only do you have stack and heap allocated data, but you have stack and heap allocated instructions that are executing. You know, like not like anonymous functions, like actual like instructions that are being executed at the time. So that's quite interesting. Okay, so there's different states. There's active, completed, cancelled, settled. Okay, so same thing. Uninterrupted, interrupted. Okay, and you have different functions. So cancel. Yeah. Okay, so it's like yeah, I mean it looks a lot like what's it called? Like in Linux operating system, for instance, you have, is it sig sev? No, what? Sig kill. Yeah, sig kill, I think. And despite being called kill, like kill will just prompt the thing to like, yo, you know, finish up and close yourself. There's also sig something else, maybe a sig sev, I don't know, that kills it, like force quits it, but generally you can just prompt it to cancel. So yeah, this looks very, so like, yeah, so like this just looks like normal threading, whereas the structured concurrency has like more, well, it's more structured, right? Like it's tied to the scope for like kind of like almost like RAII type concurrency. So cool. And there's await. Yep. Async await. But there's no async keyword, which is kind of cool. Is it cool? It's interesting. Like, you don't mark a function async per se. I guess you mark it as suspense or something. Yeah, whatever. So wait will just keep going until the task completes. So what I find interesting about await. Oh, yeah, and it goes a cache result. What I find interesting about await is that if you were to make, if you were to call a bunch of concurrent functions with await, you get what is essentially procedural programming, right? Like synchronized programming. No, yeah, where like you have one thing after the other. So like I wonder, like, could you just have that be the default? Have things just like say they await by default, but they're all concurrent? Ooh, no. Sorry. Yeah. Like make everything have to be await to be sequential. Perhaps. I don't know. That's weird. But anyway, whatever. But it also yields, right? So like if it's awaiting something, then I believe it just yields control until it, yeah. Common task patterns. Okay. Timing, next tick. Cool. Should we call like wait until next tick or something? Calling suspense functions. Structured concurrency expressions. Okay. There's defer. Right, so you can cancel a manual thread. Wow, having defer. I mean, you don't need that because you could just use a local scope thread as well. But maybe you want to have some like special behavior, right? Like to that end, having defer is basically just like an alternative way of having custom destructors, except they're explicit, which is not. Or like the user has to define them as opposed to just being built into the type. But anyway, timing functions, yep, sleep, next tick. Huh? Unreleased feature. Bro, the language isn't even released yet, like full stop. Settings since epoch. Okay, honestly, like it's just a shame that threading in C++ isn't even like necessarily that difficult. It's just really verbose. Like the timing functions are like standard chrono duration, or standard chrono milliseconds, or like something like that. Like that's ridiculous. And there's standard this thread sleep 4, you know. Like if it wasn't for like the really long names, it might seem a bit more approachable. You can wrap the names though, and that's what I'll do. Events provide synchronization primitives for coordinating between concurrent tasks. Wait, there's an event type as well. Ooh, okay. This is good as well. Event-based programming. The event type creates a communication channel where producers signal values and consumers await them. Game event equals event int. Game event.signal42. I see. I mean, this could be used for like reactive programming, the kind of stuff you get like in web development. I think it speaks volumes. Like right now, I'm using Leptos to make my website in Rust, and it sucks, dude. I mean, for reasons besides the concurrency, it's more just so that the macros make everything like 10,000 times more complicated. But yeah, like that wants to use reactive programming, which is interesting. Consumer awaits values from event. Game event.await, like await a signal. Cool. Yeah, I'm a big fan of this like event-based programming approach. Looks very fun. Sticky events. While basic events deliver each signal to exactly one awaiter, sticky event remembers the last signal value and delivers it to all subsequent awaits until a new value is signaled. Okay, so that's a different type. 100, 100, 100. What? They excel at representing state changes that multiple consumers need to observe. Unlike basic events where each signal disappears after one await, sticky events maintain the current state. Consider a game phase system. When the phase changes from lobby to playing, every system that checks the phase should see playing. Why can't that just be a variable? I assume there's like a none as well, potentially. So like an empty state. The sticky behavior creates a form of eventually consistent state. If a task awaits a sticky event, it is guaranteed to see the most recent signal, even if that signal occurred before the await. Okay, this is also unreleased. Subscribable events implements the observer pattern, allowing multiple handlers to react to each signal. Unlike events where awaiting tasks explicitly wait, subscribable events let you register callback functions that execute automatically when values are signaled. Right, so I subscribe, then I put in my thing. Yeah, it makes sense, I guess. I don't know why that needs to be subscribable. Like, why can't I just do that with normal events anyway? Because I'm pretty sure you can with have callbacks for just like general event things in C#. I need to get back on. What do I need to? I don't know. It might be a good idea to play around with concurrency, not by like Rust or something, but literally just by using C#. And working more on my game. There's an idea there. Each subscription returns a cancelable object that lets you unsubscribe by calling cancel. Once cancelled, the handler stops receiving signals. This provides fine-grained control over handler lifetimes. Wait, what? Oh, I see. Cancel the logger. Okay, cool. Subscribable events shine in broadcast scenarios where multiple independent systems need to react to the same occurrence. When a player scores points, he needs to update, yeah. Okay, and the awaitable and signal interfaces. Events are built on two fundamental interfaces, but you can use to create custom synchronization types. Ooh. Yeah, so why... It says that subscribable events are not yet released. I feel like that can just be built into the basic event type. But yeah, so you can create your own events as well. But like, it's an interface, right? I mean, yeah. Like, it's effectively just like a standard library thing, isn't it? Like, it doesn't even need to be built into the language. Like, just have it be like part of like a built-in, like just have it part of the library, right? I assume that it can be implemented in Verse. But okay, this is a good interface to think about. Same chapter? Yeah, concurrency. Events and synchronization. American spelling. The awaitable and signable interfaces. Signalable. Our English is so... This is a useful pair of interfaces to keep in mind if I want to implement my own event system. Alright. The original interface represents anything that can be waited on, symbol, yeah. You can pass waitable parameters to functions that should only read from an event, preventing accidental signals. Okay, I see. Yeah, okay, yeah, that makes sense. For that use case. I almost wonder then, like, having that be an effect instead. Like, may await, may signal. But I mean, yeah, like, it should be on a type level, so. Transactional behavior, every event subscription, like, per argument. Event subscriptions participate in Verse's transactional system. If a transaction containing a subscribe call fails and rolls back, the subscription never takes effect. Actually, there's something to say there about inheritance, and how that could also apply to functions. Like, rather than having suspends as an effect, like, have a suspends type or interface or trait that function must also derive from, you know? Because we usually only think about types applying to variables, but like having functions as well. Like, take Haskell for instance. You have I/O, which is literally, well, I/O is like a technically on the arguments level, like the function arguments. But when we see I/O in a function's type signature, in the return type, you know, like it indicates that it's an I/O function, right? The same thing doesn't really exist in Rust per se. Like, you might say it's like a function that returns an optional result, you know, or like a result type, but like you wouldn't say like it's a function that is capable of awaiting, you know, something like that. I wonder if a language... I wonder if an effect system could be implemented via a similar system to interfaces / traits for types, rather than a separate syntax, rather than a completely separate system. you could just have, yeah. The idea would be that functions can follow traits in the same way variables can. Functions are values in functional languages, so I don't see why this couldn't be the case. Transactional behavior. Event discussions participate in versus transactional system. If a transaction containing a subscribed call fails and rolls back, this discussion never takes effect. Okay. Event patterns and use cases. That's fine. Yeah, so that's by far the most attractive part of this language, is what I'm seeing. Limitations, okay. The interaction between iteration and certain concurrency expressions requires a careful consideration. Rush and branch cannot be used directly inside loops or loop or for bodies. A restriction that prevents unbounded task accumulation. When you write a loop that might execute hundreds of thousands of times, allowing rush or branch directly would create that many background tasks, potentially overwhelming the system. This restriction forces you to be intentional about creating background tasks and iterations. It's weird. Having that as like an excuse to say you can't do this, but you can do this with a workaround, but it just takes a little bit of friction, so it'll make you think harder. Not necessarily. What's the issue with this? Sorry? It creates too many tasks. Like, it's still possible here, so I don't know why I wouldn't be able to do this here. Like, I don't like it when languages do things like this, where, like, rather than, like, it's cool when, like, the language helps you to not make, like, logic errors, or just straight up, like, type errors, you know, and, like, stuff like that, syntax errors. But, like, these kind of things where it's, like, trying to force you to use best practices by, like, making bad practices not just less convenient, but, like, less convenient in a way that isn't even necessarily, like, that intuitive. This is what creates not, like, an appreciation of, like, okay, yeah, I'll avoid doing that, versus literally just being, like, annoying. Like, this is just annoying. Because, like, if I need to do this, I want to do it without having to wrap it in a function. So that's just not nice. But, like, is there a workaround to this? I mean, like, is there another way to do something like this without creating a loop? Like, if I need to rush it 10 times, I'm gonna rush it 10 times. Like, I don't understand. It's like, this language doesn't have anonymous functions, which is another issue here. Like, if I could wrap this in an anonymous function, then that would make sense. But, like, rush itself should probably be a function of some sort, rather than like an expression. Abstraction of implementation. Verse deliberately extracts away the underlying threading and scheduling mechanisms. You will not find thread creation APIs, local storage, or explicit segmentation primitives like mutexes or semaphores. This is not a limitation, but a design philosophy. I mean, it is, well, okay. By working with high-level task abstractions, Verse eliminates entire categories of bugs. No data erases, no deadlocks from incorrect block ordering, no forgotten unknown calls. The concurrency model is cooperative rather than preemptive. Tasks voluntarily yield control at suspension points rather than being forcibly interrupted by a scheduler. This cooperative nature makes reasoning about concurrent code easier. Okay? And then interaction, sorry. The effect system that makes versus concurrency safe also introduces some restrictions. The sides cannot be combined with a suspense effect. This separation keeps the failure model and concurrency model orthogonal. Transactional operations and certain device-specific operations may also have restrictions when used in concurrent contexts. So a function that suspends cannot fail. I wonder if that makes anything particularly, like, problematic. But I can't think of anything right now. And then you got live variables. Yeah. Why are there so many? Why is this so long? You can turn off live tracking. It's weird. There's await, upon, and when. Suspend until X changes from old X. Sounds like an event system almost. Yeah, I wonder if this is any because like there's a wait, there's a pawn, and there's when as well. So I wonder if this has potential to replace parts of the event system. The batch expression groups multiple available objects together, delaying notifications until the entire group completes. It makes sense, yeah. Issues and patterns. Yeah, why would you make it live after the fact? I don't understand that. Failures and liveness. Okay. So there's an issue with the failure system. Oh, the cracks are starting to show. Derived synchronization. Conditional reactivity. Resource loading. Yeah, literally. Yeah, so like you don't even need like events. That's crazy. Common errors. Okay. So with the live variables, I wonder to what extent live variables make a dedicated events make the existing event system obsolete. Evolution. When publishing a new version of a system, okay, don't care. Modules and paths. Nothing too interesting there. Persistable types. Right, so this is like saving, right? And you can make custom ones as well. It's interesting. JSON serialization. Huh, okay. Yeah, it's kind of weird. Like, why not have like a... Like, if this was like a trait system, you could instead have like a savable trait, right? A savable trait, or like a save trait, which just basically means that it can serialize to save data, and then have like JSON to JSON be like some function there. I don't know, whatever. Or I guess like serializable would be that trait, wouldn't it? But okay. Oh, there's more. At its core, VerseSpace is the theme of principles shaped by code evolution. So, future-proof design, a metaverse-first approach, whatever that means, bro. The nature of code application. When they publish it to metaverse, they enter into a social contract with all future users of their code. It's not just a convention; it's enforced by the language itself. Okay. By marking a thing as public, you're marking a commitment that extends indefinitely into the future. Users can depend on the thing always existing and always being an integer. how does this like whole metaverse thing work? Like, can you like interop with other code? Is that how it works? Because then surely you're gonna get like a whole like pile of just outdated code that no one wants to touch and like interact with in the metaverse because it's like just not even worth using. While you retain the freedom to change its actual value, but the existence is permanent. What's an island? Because I mean, obviously I missed that. I guess it means like if people make mods for your game, for instance, for your metaverse creation, then those mods won't ever break. But like they could break like through other subtle ways though. Unless you don't unless you don't make the wrong assumptions, right? As the mod creator, and like take advantage of what you can rely on. There's a version system, right? Bruh. Epic Games retain superpowers to make breaking changes outside the normal compatibility framework. Okay, bro. Right. So people also what's the word? Incentivized to not over affect it, like only use affect conservatively. Which, fair enough. Although the way the effects are like the hierarchy of the effects is a bit weird anyway. If it was more, if they were all additive effects, I think it'd be a bit more easier to reason about. Okay, that's it, right? What? A violence warning at the start of the video?
Hey everyone, we're back to talk about Verse, the new programming language that we've been designing for the metaverse. So Verse is about solving the larger problem of the metaverse. Verse is launching an Unreal editor for Fortnite, but we have much longer term and bigger plans for it. But essentially it's aiming to provide a programming language solution supporting development of many kinds of games and other real-time 3D simulations, supporting a full development cycle of tools and content creation for the metaverse. I'd like to say a little bit about what we see this as ultimately, because the metaverse is more than
define a value, constant value called x. A would be 42.
For like thousands and billions of users. Have you looked at kind of alternative forward-looking ways of storing and sharing that code? Things like what Unison is doing with kind of hashing abstract syntax trees and sharing
It's Q&A.
things that way for providing.
Hashing abstract syntax trees to share code that way? Wait, hold on. Sharing code via like abstract syntax trees rather than source code is actually quite interesting. Because it means that it's not dependent on the syntax. So the syntax can evolve, but the code will still work. That's actually interesting.
Providing kind of greater scalability than traditional kind of text-based sharing provides.
Yeah, there are really two ways of doing code sharing as we see it in the metaverse. The traditional way is you want to use a bunch of libraries. Great, well, you copy those into your directories, and now you have a separate copy of the library, and you can modify them however you want, and they never change, and now they're kind of your problem to maintain. Yeah, that works for some things, but we think the much more common approach to sharing in the metaverse will be different authors deploy their own modules and expose them as public components of the metaverse. Right? You've seen that in Verse there are public and private declarations and variables. Well, in the metaverse, like, we take those things for real. If you release a public module, that means any other programmer in the entire world will be able to access your module by its path. You'll have like a path that might start at Fortnite.com right now and then go through your creator name and then have some directories underneath it. Well, that's your module that you've released publicly. And the intention is that the Verse publishing system
Yeah, that's not quite what he asked.
has backwards compatibility constraints. If you publish a version of a module that says...
Right. But yeah, so outside of the metaverse, just in general, having that AST instead, that's quite interesting. Yeah. Are there any limitations? We're sharing programming libraries as ASTs instead of source code. I mean, they're larger. I expected that. Stable serialized AST spec. Is that hard to keep stable, really? Okay. Yeah, you use comments and macros, that's fine. Two link breaks. True. Not for obfuscation, though. But like just for backwards compatibility. Huh. Have an IR instead. Yeah, that makes sense actually. Okay. But does Rust have that? I see. Okay, cool. So let's see what people actually think about this language. Augment blueprints, what?
And this isn't to replace blueprints. This is to augment blueprints. So if you love programming with blueprints, keep doing it. If you want to program in a scripting language, Verse is coming.
I'm guessing that changed. and now it is a replacement. He said it's recognizable to programmers. Exactly. Let's everyone choose if they want to use clearances or indentation for blocks, even though the rest of the language is not familiar. It's so annoying. That is far from the most egregious thing. Lack of casting for some reason. I mean, there is casting, but it's just very weird. These aren't issues. Yeah. Yikes. No one's even talking about like the concurrency, which is by far like the most interesting thing. Yeah. Right. So it seems like documentation is generally an issue with Unreal Engine. So I guess I shouldn't be too surprised that this one isn't particularly great either. Yeah. Unreal script was a thing? What's the thing? I was like, this language is, again, like, the documentation only mentions once about a virtual machine. So I don't know if this language is compiled or not. Is VerseLang compiled or VM? This is 1 month ago. Mandatory for non-trivial games. So, like, what's the point then? First looks alien if you're a programmer coming from a C-based language. It looks more familiar with has like language like Haskell, but honestly not really. Coding in fast, yes, it's faster to write code. Erlang was the first language to do the failable system? Okay. Erlang. Huh, that's interesting, because Erlang also has great support for concurrency. Wait, first, isn't multi-threaded currently? Multiple cores, yeah, good. Yeah, you know, keep a high level concurrency, not low level threat management. That's what like the library, like the language should do for you. In the same way that you don't have to write your own tag unions from scratch in Rust. Like you could, but it'd be really annoying, and the language would have to add like loads of features to kind of accommodate that. Like in C++, making your own tag union is actually really annoying right now, especially until pattern matching arrives. Because you have to use the visitor pattern, and I think that there are limitations to how safe you can make it as well. Unlike generic. Okay. So did it used to have empty if blocks? But then they changed it, so now you just so that now just happens. I don't know. I can't tell. Well, no, because you don't want it to fail everything, right? So if it fails, do nothing basically. Yeah, like it's just weird. Like the language's syntax doesn't accommodate the features well. I think if it had a more fitting syntax, it'd be a lot more appealing. But even then, like just some of the features are just really not great either. Like classes and structs and modules all being separate. I would think we can do better. Enums not being tagged unions, but just being just like tags with no values. So that's a weird limitation to have in the modern programming world. I mean, like, there'll be steps up from C++, but, you know, we can do better than just make a language that is better than C++ in some ways. Yeah, anyway. So, this is the verse documentation. Only one issue? Okay, and here's a prologue. This is a book, is it? Yeah. But what is the formatting on this website? Okay, and then there's Coca. Yep. And there's a tour of Coca. Okay. So I'll have a look at Coca in more depth then, and see what that's about. Because this is an effects language, but not for game development, so it's probably not logic based. It says functional style language with effect types and handlers. I wonder if it does anything for concurrency built in, but anyway. Yeah, so verse, kind of a, yeah, concurrency stuff was cool. It gives us, it's useful for me to kind of like explore the potential of concurrency, or like syntax geared around concurrency, you know, treating it as like a core language feature as opposed to like an extension. But apart from that, very whack. I mean, yeah. Like, it started mildly interesting and then just went downhill very fast. With decisions like having multiple syntax styles for some reason supported, so you can use braces or things, depending on whatever you decide makes sense. But like, again, it's objective, so it's not going to be based on like good reasoning. Using, you know, 0xx for char hexadecimal literals when 0 historically means octal. That's just completely given that for no reason. Multiline strings, use the brackets, use braces to separate them. As I said before, you could replace that with some new syntax later down the road, but like in the meantime, like do they really think that's okay? I assume they were only doing like that because, like, my hope is that the only reason they've done that is because they realize they could change it later if they need to. I hope that they hadn't just like put it in there and said, you know what, that's completely fine, because it's not. Boolean expressions, like having like failable, having false be void, no, having false be empty. Like, if false means empty, just call it empty. And like, why is true even a word? Like, have like fail and okay or something, you know? Like, having true and false just doesn't make sense. Like, it doesn't read like anything. The set expressions are cool. I like that being explicit. The rational's very cool. The rational system's very cool. I don't know why more languages haven't tried that. I've experimented with like implementing my own rational type in C++, but that's not really easy to do. Like, having it on a proper like language level would be, yeah, it'd be cool. Or at least having like supporting ways to implement it somehow. I don't know. Especially like games, you know, where like you want again the accurate calculations. I'll see what I can do in C++ for that, now that I understand more about like overloading and all that kind of thing. But like, even then, like writing, like it'd just be kind of a hassle, because like 5/2 would evaluate to 5/2. You couldn't have it, like you'd have to have like a tuple basically, which wouldn't read as nicely. Hence, having it be a core language feature is a lot better for that reason. And then, yeah, cool concurrency stuff, and the events stuff is also cool, but I wonder how live variables will conflict with that. So some interesting ideas, but also lots of stinky ideas. And there you go. The first programming language. I will, yeah, that gives me a lot to think about. So, yep, always good to check it out, even if it's weird, and even if I'll probably never use it, but research is good. So, Coca and Swift and Prolog. Those are my next targets. Probably, I mean, if I find like a decent Prolog guide that isn't like a pain to read, like visually. Otherwise, Coca and Swift. It's actually, yeah, Swift. I mean, I'm gonna learn Swift this year in university, but I believe I've already completed the language tour anyway, like the overview. So now for Swift, what's left is just reading the intricate details. So what I might do is probably just skim through it, honestly, and kind of like skip stuff that isn't as important, because like at this point, I don't know how much I can really reap from it. Yeah, like, cause like reading these whole like these whole documentation things, like it takes so long, and it's quite tiring. So anyway, subscribe for more programming language design.